Welcome to Microfocus Universe 2021 and welcome to this session on voltage for test data management. My name is Jean-Michel Guéral, Voltage Data Privacy Solutions Practice Lead. In this session, we are going to see how voltage helps to generate realistic fake data that represents the reality so that the testing can happen properly. So we will go through an introduction on our vision of test data management. Then we will see in a demonstration how it looks like to mask with voltage and especially how the testers will consume this test data. And then we will go in more detail with demonstrations on how we build that and how we discover sensitive data, where are the columns to protect, how to generate meaningful dictionaries, to generate contextual masking functions, also defining the masking strategy that will allow to have consistent masking across applications, and finally how to generate the masking policies. So let's see what about voltage for test data management. So we can say when we deal with data, we need to take into account that the data are the treasure everybody wants to have, and it needs to be protected. The risk of fine due to compliance or data breaches can have a huge consequence on brand and reputation. So why it's important now? First of all, it's about cost. Think about how many environments organization needs to manage. Usually there's a ratio between 1 to 4. One production instance will have a development system, test, training, certification, and so on. So this is about cost to replicate the data everywhere in the organization and in the information system. It's also about complexity. It is complex to ensure that the testers have meaningful data and in the meantime, not the real data. This would be a breach in the security level that we want to implement in the organization. Because it's simply a risk of copying the data from production to test environment. Even if the tester sign a non-disclosure agreement, that may be not enough for a regulator. So what are the challenges when we deal with test data management? So on one side we have DBAs. They are here to manage databases and they have many other tasks to do in the pipe that can sometimes be higher priorities than creating test data. And often also copying and anonymizing data. It is a manual process in the organization. It's an activity that is error-prone and that can generate bad quality data and therefore bad quality testing. The second party in this game is the QA team, the testers. They are often distributed and sometimes outsourced. So that can be also a bridge to give them production data. We have also to keep in mind that running tests burns the data. It burns the test data and it deletes it. We do deletion, modification, and so on. So we need to refresh this data periodically and sometimes multiple times a day when we are in a test campaign. And finally, we can talk about the compliance and security team. Given clear production data is not an option for them. It's not best practices. It's not also acceptable for regulation to do so. So we have to make all these people working together, make sure that they are all satisfied with the environment and work in an efficient way as well. So for this, Voltage has a solution to help with these test data management or TDM challenges. So what do we propose? You can first connect to all databases that exist in your information system thanks to the use of JDBC standard. So why it's important? Because databases are diverse in an information system. I would say heterogeneous is the norm. You can also discover sensitive data with the tool. In these repositories of information, the databases, it uses an intelligent engine with out-of-the-box rules to identify what columns are sensitive and have to be protected. So why it's important? Because, well, you cannot act on what you don't know. It gives you visibility on the information and the sensitivity, calculate the risk score of the different environments. Then you can subset your production database to focus your test on the data sets that really matters. Imagine you want to test customers in Germany. So you can extract only the German customers' information so that you will optimize your footprint, reduce the risk as well. And all of that is extracted in a consistent way and matching the defined criteria. So why it's important? It reduces the storage, it reduces the risk exposure, it reduces also the consumption of all the IT elements, CPU, disk storage, and so on. You can also generate test data with the solution. So it can be from scratch, or it can also be from the production data itself that we shuffle in dictionaries so that the real data is used to create the masking data. So why it's important? Because data looks in that case super real, as it is similar to what you have in prod, except that it's shuffled. You can then finally mask with these dictionaries or also with a format preserving algorithm that makes things look real again. Moreover, it can keep the integrity across applications, across the multiple runs that you will do, and even maintaining the context in the row. So look, for example, if gender column is female, then for the first name column, use the female dictionary. So that will ensure consistency in the row and therefore ensure that your test data quality is as best as possible. Voltage proposes to its customers an architecture that helps managing the full complete TDM process. This is what you can see here, the concept overview. On the left, the DBAs in the IT department first discover information, as we saw, any sensitive data, because knowing the sensitive data allows you to define the proper masking rules. This information is then used to create automated scheduled tasks to optionally subset, copy, mask, and store this data in a central test data library. So that's something we often propose because it allows to segregate the two environment, production and test. Then the testers, they visit this library with an app in a browser, and they trigger the solution to carry out an automated refresh of their test data, so without the need of the DBAs, and with no impact on production because we are connecting to a separate environment. So why this is all important? For three things. First, this is for security. It separates the two environments. Testers do not have access to production data at all. This reduces the exposure, the risk on data leakage. For compliance, secondly, the testers only sees the obfuscated or the anonymized data, encrypted data. You are in compliance with data privacy rules. Thirdly, last but not least, for operational efficiency, IT staff may only refresh the test data library once a quarter, for example, but the tester will be able to refresh their test data 3 times a day if they wish. So this without impacting the job of IT staff and without impacting performance on the production environment. To support fully this concept and architecture, Voltage has introduced a TDM module to ease testers' task to refresh their test data set and improve the operational efficiency. Because testers are familiar with concepts like test suite, test cases, they are not so much comfortable with running data movement jobs. This is not their cup of tea, I would say. So this module makes the link between the two. It hides the complexity for them. It allows the testers to request a refresh of the data in their test environment, of course. This module will do the mapping with the technical actions behind the scene to extract the data from the library, extract and mask the data. So why it's important? Again, you understand now this is a way to improve the operational efficiency. The testers are autonomous. They can do their job without constantly requesting support for IT staff. So let's recap the architecture and concept that we have introduced here with an overall architecture with maybe a bit more details. So first of all, you see on the left that we extract the full or partial data from production. We are able in this process to anonymize it, to store it in a central test data library managed by the solution, the Voltage solution. And now testers can extract test data from this test data library, put it in CSV files, for example, and upload them in their test system. So they will be able to consume the test data as much as they want. All right, so let's summarize what's the value of Voltage and test data management. The main point I would say is it enables to generate realistic fake data that represents the reality so that the testing process can happen properly with the best quality of test data. It reduces the risk of a breach. It masks in a timely manner as soon as possible with a rule-based consistent engine that will procure a repeatable way to mask the information across all the system. It brings an outstanding test data quality with contextual masking in the row and also consistency across databases and also across runs. It also improves the automation, and that's an important point as well. Improve efficiency with a flexible engine, open engine that can also be customized to your exact processes in the organization. Let me now show you how TDM with Voltage solution looks like. In this demonstration, I've taken the use case where we will extract, mask, and store as a CSV in one step. As you've seen before, we would sometimes recommend to have it in two separate steps to separate the two environments. But let's make it simple here. We will have a look in this demonstration how we can define a testing project with test suite and cases in the tester's environment application. We will generate or refresh anonymized test data, and we will compare it with the data source to have a look at this information that we have modified. So this is our application. We have a set of modules, but the one that really interests me is this test data management module that will help me as a tester to configure all this environment for my test data. I have here a first dashboard that shows me how I've been working in the recent days. You see I've been doing some tests already. A tester will certainly start in this application with creating or modeling, registering its application to tell the system what application we are working on. So here I've registered my application. It's called DMARC. It's an ordering management system. We have several versions, and we have multiple modules, one for managing the orders and one for managing the customers. I will more focus on this specific part today. Then, on a day-to-day basis, the tester will most of the time work with projects. Projects are here about a set of tests we want to do about a campaign, a test campaign. When we create a project like this one here about my DMARC application, project 1, we will have the chance to create for this project a set of test suite. These test suite will allow me to cut my testing in different use cases in my application, for example. So here I have different test suites for ordering management and customer management, where I will test all the customer functions. And again, I can drill down a little bit and go to the test cases. A test suite will be composed of different cases that we want to test in our application. So that's a typical way a tester is used to work with a test environment, test suite, test cases, and we are here matching this type of working. So here I have a set of test cases I've registered, like create customer, and you see I've mapped it with business flow, and that's the mapping with the technical function that will do the job behind the scene. But for the tester, it's transparent. I will just need to click on this run button, and this will allow me to trigger this application, this business flow as it's called, to extract the data, mask it, and generate this CSV file that I need for my test application. And I will be able to import it in my application. So here I have the possibility to run this case. So let's run it and wait a couple of seconds. That's a way to really, as we see, mask the complexity of such environment for the testers. They will not have to get into a technical interface to look at what job I need to run. That would not be something they could do as they are not trained for that. This is also a simplification, because most of the time what would really happen is they would open a support ticket and call the IT staff, the DBA, and say, hey, I need to refresh my environment because I need to run my test on the fresh data. So can you do that as soon as possible? Here, as you see, without any call or support ticket open, I can click on a button and get a refresh in few minutes. Once the job is finished, I have the opportunity to go in the history here and look at all the runs I've been doing for the generation of this data, and I will be able to download this information as I've created jobs that generate CSV files. So here my next step will be to download this CSV file. I see now the runs, and the last one is this one here, the first one in the list. And you see with this icon I can download my files, which is now ready and have been made available for me. I just click on download button, download here, and my file appear here. So let's open this file and have a look at the information inside it. I have also here a small application that connects to the database and give me the information in the source. And we will see that we have been keeping the same format as we expect. We have, for example, Jack Jones here that became Sadie Gilmore, and we have transformed telephone numbers, email addresses, but everything keeps the same format. It really looks like a normal database. Even if a hacker would enter our system and look at this database, he would hack some garbage and wouldn't know it. We see also that credit card numbers have been masked, but we have kept the 4 first digit and the last 4 ones in order to have consistency with some information provided by these digits. Same for social security number. You see the last digits are not obfuscated here. So you see this really look like realistic data that can be used by a tester for best quality test as possible. So what we've seen in this demonstration is with voltage test data management solution, we have an interface for the testers that allows to refresh, generate and refresh their test data by themselves, being autonomous, not asking IT support and not necessarily connecting to a production environment, while having something which is protected. It's realistic fake data, as I can call it. It's data that looks real, but it's completely anonymized and obfuscated. What we can do now is get a bit more in detail in the process and see how we have done that. What's behind the scene and what are the different steps to get to that. So first of all, we'll see how we can identify sensitive data column, how we can evaluate the risk in our database and focus on the right columns to protect. Then we will see how we can generate dictionaries to mask information intelligently. And after that, we will see how to generate the masking functions that will use the dictionaries, but also algorithm to generate realistic data. And finally, we will see how we create these policies, these business flows, as I mentioned previously, that tester will be able to run via this interface. Let's have a brief look at how voltage solution allows to identify sensitive data in columns of databases to get visibility and know what to mask. So what we will see in this demonstration is we connect to data sources, to repositories of information, scan them, get information about the different columns and what's inside the columns. And the engine will calculate for us a risk score. So we'll have a look at this risk score. Also be able to analyze more in detail how we will review the findings, get all the information that allows the users to do this review process. We will also see how the engine classes automatically categorize the information in different PII classes. And finally, we will see what's behind the scene, what are the grammars that allows us to do this scanning and identify this sensitive data. So what we have here is the front page of the solution, and here we have a module called Discovery. And this Discovery module is the portion where we will be able to do all this job to discover the sensitive data in our databases. In this discovery portion, I have already configured a project. So the project is linked to an application. I want to review an application. and I create a project for that. So here in the front page, in the dashboard, I have an overview of my project with the different stages and sensitive data I've found and the different classes of sensitive data. But let's have a look at this project in more detail, and I will explain you how we create the project and what's needed to get to this point. So in the project, we have a front page. This front page appears when we have started the project. Let's have a look first at this front page. We have here some information which is interesting, like the status of the project, where we are in the review process. We have here reviewed a lot of tables, and they are identified as sensitive. Some of them are safe, but some still need to be reviewed because they are suspect or not suspect, but still we need to have a look at it. We have also this classification I was talking about in terms of PII, different categories that are coming out of the box. PII, sensitive personal data, contact information, PCI, which is credit card numbers and things like that. This is coming out of the box, but you also have the possibility to create your own ones if you have some need to have specific categories and classes. Here we see also the risk area. We see a risk score, a global risk score that was calculated for my project, for my application, and all the tables that were scanned with the different risk score. So immediately I visualize that this table, the customer table, looks very sensitive, and this is probably where we want to focus on in terms of protection. To create a project that's very easy, you connect to create a new project. It will ask you the connection to the database, and then you give it a schema. The schema will allow you to discover the tables available in the database, and in this table you will be able to register more or less tables. So maybe you want to scan all the tables. That's obviously possible. Here for this example I've selected 2 of them to speed up the process. So here we see in this list of tables that we have worked on this environment already. We have reviewed this customer table. This is already finished. We have sensitive data, we have safe data. If I get into this customer table, I get more detailed view on the columns of this table and what was found in the columns, what we have assigned in terms of sensitivity and sensible types. So we see here all the columns. This is all calculated with a risk score, as I said. So we see here some of them are more sensitive than others. It may depend on the number of items that we have found in the columns. It also depends on the weight that we have put on the sensible types that we have in the system. So here we see example of sensitivity types discovered in these different columns, like first name, credit card numbers, telephone numbers, email address. And if we get into the columns, this is where the person, the analyst, the data analyst, will be able to review what was found by the system and identify if it was properly classified or not using the different patterns that were discovered. So here, this is coming from a dictionary, actually, dictionary of names. We found family names, first name. We have also looked at the alias of the column, so that we, with that, the system give me a result. We see the hit ratio is really important for the first name, so that's probably a first name sensitive data. Okay, and here for each of these columns, these tables, we have the possibility to review them one by one and say this one is, I confirm this is sensitive, this one is a false positive, this is not sensitive because I know this information. You also have the possibility to review the tables massively, I would say, with selecting the table and going to mass review and confirm or not things. All right, so here we have our project, and step by step we will review all of this, how the thing were discovered. This is based on a concept that we call grammars. These grammars include different things. It includes dictionaries of information, a lot of words in a dictionary, like names of people in different countries also. These dictionaries also are complement with regular expressions. Regular expression, this is when we don't know the exact values, but we know the shape of the information, like a social security number, for example, that will have a specific format. So a lot of rules are pre-configured in the system. As you can see, you can configure your own ones if needed, like a document number if you wish. We see here all the classes that were configured out of the box, but you again can configure your own classes. And all these patterns are available in many different jurisdictions, many different countries in the world, so that this could work in an international context. You will be, of course, able to activate or deactivate these different patterns depending on your context. These patterns are organized in different types of patterns depending on the sensitive data we are looking for. Many different types like first name, last name are based on dictionaries. As I say, we also support regular expressions. This can also be date ranges, numbers, and if we get into the detail of these types of patterns of entities that we want to extract, like social security number, here we will see the regular expression assigned to these different patterns. There could be many. Here in this example, the pattern is different depending on the country. And as you associated to that, you can also, in case of regular expression, associate a validation script that will calculate a checksum to reduce the false positive and make sure that this is a proper social security number in this case. So based on all these grammars, the engine will scan the environment, more or less information inside the table, and that's one of the strengths of the system. It allows not necessarily to scan the whole table, but to do a sampling in the table. Let's say scan 10% of the information, which will speed up the process extremely. Then the last thing we can talk about is the possibility to document all of this. We have gone through a review process and identify the sensitive data, verify that this sensitive data was properly identified, but a regulator will certainly ask us to prove that we have gone through this work. And here we have the possibility either to show this interface or to record a report, and this report can be extracted in a PDF format, sent to our records management system so that we archive it for long term and be sure that if an auditor comes, we are able to provide it. Okay, so in this demonstration, we have seen that we can identify the sensitive data in columns of tables. We have hundreds of grammars that are available out of the box, but I can obviously do my own one if needed. And this interface will allow me to get visibility, to evaluate the risk, to find out where the sensitive data is and where to focus on because of this risk score that will allow me to identify what columns and what tables are the most sensitive information, and this is probably where I want to start with the actions. Voltage masking solution allows to generate dictionaries of data to use for our masking functions. So in this demonstration, we will see how we can use the out-of-the-box dictionaries. We also see how we can reuse the data in the source database, shuffle it in order to generate new dictionaries that looks even more close to the data that we have in the source. We will then see how we can compose more complex dictionaries, for example, for comment fields with a combination of words and dictionaries and so on. And finally, we will see how we can map dictionaries in order to ensure the consistency in the runs and across databases. So let's get back to our project. We have scanned our environment, our database. We have identified sensitive data. We know where are the columns that are sensitive, and now it's time to remediate. For that, we will go in this remediation menu. But let me show you first this folder here. That is the folder where we will see appearing these dictionaries. Let's click on remediation and you see an option generate masking. So generate masking, this is where we generate these out-of-the-box dictionaries from the data which is part of the solution. From there, let's go back into our folder here. We will see appearing our dictionaries in a couple of seconds. Here they are. If I go in the dictionary folder, here I see several dictionaries appearing step by step. For example, first names. So let's have a look at this one. This is simply a list of names, first names of people. Okay, so plenty of dictionaries available out of the box here are usable for our masking functions that we will see later. We have also here different possibilities to run the masking function on these dictionaries. And here we see something that we will see probably later in the demonstration, how we can map the dictionary. So different capabilities, different functions that will be available for the masking, either a random use of the dictionary or a mapped use, meaning that the first time we run it, it will randomly choose a word in the dictionary, and the next time it will always use the same word for the same value. So Paul become Joseph the first time, next run it will always become Joseph. That's important for consistency. If we run the job for several databases, or if you run the job several times on the same database. If we get back to our project again, let's have another look at the remediation capabilities. So here we see that we have also the possibility to generate shuffle SQL. Actually, this function will generate scripts based on the columns and tables that we have here in our project in order to capture the information from our source database. And this will allow us to then create dictionaries from this data. So we will shuffle it and generate then new dictionaries from this data. So I've now created the functions. I can go back here and generate the shuffles. Generate the shuffles will generate my new dictionaries. Go back here in my masking. Dictionaries. Let's wait a couple of seconds. Start to appear. So you see now new files with project one, first name. These are new dictionaries. They are made from the data that I've captured from my source database. The big advantage here is that I will be able to have something that really looks like what I have in the source database. The testers will not be disturbed by the new words that could come from out-of-the-box dictionaries. Here there are really data coming from the source database, and obviously they are shuffled and we will not be able to recognize them. The last thing we can see is the possibility to generate complex dictionaries based on a combination of different properties, and here is where these dictionaries are described. So just show you these compositions and how we define the compositions. So here what it means, for example, we will create a dictionary called not UD, and this dictionary will be a list of 100 values composed of the dictionary first name, space, last name, and some text, is from, and the dictionary country, and so on and so forth. So here we describe what we want to see in this new dictionary. Let's have a look how it looks like when we generate it. Go back to our project, go in remediation, generate compositions. That's the name of this function. Click on generate, and this will start to generate these dictionaries. So let's go back at the dictionary folder and see what it looks like. My dictionaries, not UD, that's the guy. Edit it, and you see we have a list of more complex values that we will be able to use in fields like comments and things like that to generate an even more realistic database for the testers. All right, so we have seen here that we can generate meaningful dictionaries. These dictionaries can be made from scratch or from the existing data in the source application. This is meaningful data. It can look like the real data. It's shuffled from the real data, and it really looks like names if we are talking about names, or last names, or email addresses, and so on and so forth. And it's a repeatable process. It's consistent in time. So if you run the process multiple times, you have the possibility to get the same value for the same original field. And it's consistent across databases. So if you have multiple databases with the same field, you can assign the same value and mask them with the same value to keep the consistency between your different systems. And that's an important point for testers when application goes across databases. Voltage masking solution allows to generate masking functions. These functions will be used by the masking engine to obfuscate the data. These functions will use the dictionaries and also algorithm to mask the data. So what we will see in this demonstration is the out-of-the-box functions and how they can be customized. They are a function that are context-aware, meaning the function is called with the complete row, giving the context around the columns that we want to mask. So let's get back to our project. You remember we have gone through all the process to review the data and gone to remediation in order to generate the masking and the different dictionaries. So this has created dictionaries, but also function. Each dictionary receives a function attached to it that allows to run this masking job for this dictionary. So for example, if I open this first name Groovy, Groovy, that's the name of the functions. This is actually JavaScript that allows to openly be modified and customized if I need, if I want. And the thing is that you will see here that this masking function will receive as input the object containing the complete row of the data that we need to mask, even if we want to mask the first name column in that case. This masking function here for the moment is using the first names dictionary, but we would be able to customize it. Let's imagine we want to have something even more realistic in our mask data. We can imagine we have a selection. If the gender is female, then use female first name dictionary. If not, use the male first name dictionary. And that would generate a masking environment that is even more concrete and realistic for the testers so that they are not disturbed with the obfuscated data. These masking functions concerns the dictionaries, but also the different functions that are not attached to a dictionary, like for example credit card numbers, social security numbers. So you see that we will have here functions that will generate this social security number and allow us to have randomly social security number in our system. This function could even call an external party to generate a mask. That's what we could do with a combination with our encryption engine that could be called to mask some PIIs, and we will see that later. Okay, so any type of PII can be masked, and we have seen in this demonstration that the masking functions are context aware for a more realistic test data. They are out-of-the-box functions, but you can customize them or generate your own masking functions that will be used for the masking engine. It concerns any type of data. It can be numbers, dates, regular expression. We can also put validation scripts, and it will adapt to any data in any type of database. Voltage masking solution allows to define global masking strategies so that the masking policies are applied consistently across databases. So in this demonstration, we will see how we can assign masking functions to each environment type, whether it's production, test, QA, training, and so on. And we will see how it ensures the consistency in the generation of the policies across all databases. So let's get back to our demonstration environment, where we have here in this module the possibility to go to grammars and masking. And this is where I will see this mapping between the entities that we are able to capture and identify in the content of our database, like bank account numbers, credit card, cities, countries, all these sensitive data, and we will map it with functions to mask this information. And you see that we have a set of columns here, depending on different environments that we will have. Different type of environment for production, tests, dev, QA, or training. We are able to set different policies to mask these environments. Setting up these policies allowed first to map policies to the different entities that we identify, but also to have a consistent way across all the databases and applications that we will mask, because for each of them we will repeatedly use the same algorithm to do the masking. So if we get back to our project here, we will see something important in the project where we have discovered all the sensitive data. We will need to specify what's the type of the source of data. And this is done in the properties of the project where I see the source type. I've defined it here a source type as test. So this means I will take the second column of my table that we just saw earlier. Right, so when I'm set like this, I have the possibility with this tool now going back into this menu for remediation to generate the project. Generate the project will take all the parameters that we've just seen, take all the columns that we have identified in this project and the tables, and do the generate a project that we will be able to then compile, if you want, or deploy into our environment in order to run the masking policies. So generating the project will generate a file that we see here, and this file I will be able to ingest it, incorporate it into my project. For that, I need to go to this small tool here that allow me, the designer, to compile, to deploy this project, to generate the project. To import the project that we just generate, I just need to create a project. Let's call it my project. Point it to the database. I have an empty project here, and then I go to import existing project. I'm in the right directory here. Import the project. This is a warning message because I did it earlier, and now I have my project incorporated. So let's get back to the one I just did earlier to give you another view of what's inside a project. The first thing we can see is the so-called models. This is what we want to act on. So that's, in our case, the customer table. That's the entity, the categories of information in the database that we want to look at. Then we have the so-called cartridges. This is individual actions, tasks that we will be able to do on the data. And finally, we have the so-called business flows. That's the policies that can use one or more of these cartridges. And that's the application, if you want, that will be available and that we will be able to run to do a specific policy. But let's have a look at this specific one. D2F, database to file. In this example, I wanted to show you that we can both extract information from the database and at the same time, so extract it into a CSV file in that case, and at the same time do the masking function. So here I have my action database to file. The operation that we will be done with this action is on the customer table. I will copy the data. That's my goal here. And I leave this checked out, purge, because I don't want to remove the data in my source. If I check this box here, it will mean I'm doing a move from source to target. So that's the action, but in the meantime, I specify in this data masking tab all the functions that I will use to mask the data. So you recognize here my customer table and all the columns for this table, and this is all the functions that we have specified in our parameters in the module that we saw just earlier. So automatically this has been populated for me, and I just here have to right click the application, the business flow, to export the data, deploy it, and it will generate, so kind of compile this application and ingest it, incorporate it into the engine so that we can run it. And this will then appear in our application here that allows me to manage these business flows, so these policies that we can run on the data. So I go in the launch business flow, and I find back my flow that I compiled just before. This business flow, this policy, I can run it from this interface here. I can also schedule it periodically. I can run it from any tool with a command line, so I can put it in a workflow engine or something like that. It's just a command line to run here, and obviously I can run it from the TDM, the Test Data Management module, that will use these workflow, these business flows, to generate the data. So that's exactly what's behind the scene of the TDM module. The TDM module will hide this complexity, I would say, to go into this part and find the right flow corresponding to its test. It will do the mapping with these two and run the right business flow for the user. So here we see that we have defined masking strategies to have something consistent across all the functions that we run across the different type of environment, so we can be consistent in the way we manage these masking policies. This will be repeatable because it will be always the same strategy and the same policies that will be applied on the data across the different runs and across the different databases that we have in our environment. This concludes our session on voltage for test data management. Thank you for listening.